Hey everyone. Today we are going to talk about rate of change and slope. So rate of change we've looked at already once this unit, but it is how one quantity changes in relation to another quantity. Sorry, spelling's hard for me, so it's hard to talk and write at the same time. All right, so how we've looked at this is that was when we talked about m equaling the change in y over the change in x. So our rate of change was we were looking at patterns and how y changed and how x changed. So first today we're going to look at that on a graph. So it says find the rate of change from 2011 to 2012. So from 2011, that's starting here, and going to 2012 is here. So the change from there, when we talk about rate of change, it's going to be the change in y over the change in x. So the change in y, this is our y-axis. So we're going up 1, 2, 3, 4, and then we're going to the right 1. So we went up 4, over 1. So notice on the side it talks, this is rounds in a spelling bee. So our y-axis is rounds, and then our x-axis is years. So on the top, we went 4 up, so there were 4 rounds. And then the x-axis, we went 1 to the right, so 1 year. So our rate of change was 4 rounds in 1 year. And then if you can divide that, you should. So 4 divided by 1 is 4. So 4 rounds per year. So it's kind of like driving like miles per gallon, miles per hour. This is rounds per year. Next one is rate of change from 2012 to 2013. So 2012 starts here, 2013 ends here. So we're going 1, 2, 3, 4, 5, 6, and then over 1. So we went down 6, so we went negative 6, and then over 1. So we had negative 6 rounds per 1 year. So we would say this as negative 6 rounds per year. Finally, we have find the rate of change from 2012 to 2014. So we're starting in the same spot again, but now we're going to 2014, which ends here. So we're going to go down 1, 2, 3, 4, 5, over 1, 2. So we went down 5, so negative 5 over 2. So we lost 5 rounds in 2 years. So if we divide that to get a rounds per year, we would have negative 2.5 rounds per year. So that's kind of how it looks on a graph. So we're just kind of counting how we change in the y direction, and then we're putting that over our x direction. On a table, we've actually already seen this. We did this like a unit or two ago, or a section or two ago. So how it changes here, we add 1. Here we're adding 1, adding 1, adding 1. And then on the y, we're changing by subtracting 3 each time. So if that rate of change stays constant, and it's adding and subtracting, we know that it's going to be linear. And then our rate of change, we're always doing the y over the x. So our change in y was negative 3, and then our change in x was 1. So that is our rate of change. B, you might notice there's kind of a typo. They're missing some numbers, so we're just going to cross B off. Then on C, here we're adding 3, adding 3, adding 3. So look, so far so good. Here we subtract 1, subtract 1, subtract 1. So this is linear. We're adding and subtracting the same numbers. And then our y goes on top, our x goes on the bottom for our rate of change. Finally, this one we are adding 5 each time on the x's. And the y's we are subtracting 2. So again, linear, you're adding and subtracting, same thing on each side. And then our rate of change would be negative 2 over a positive 5. So that's kind of review what we've already done. So that m, that rate of change that we were just talking about, is another name for the slope. So slope is another name for rate of change. And what we're looking for is we're looking for the steepness of a line. And the letter we use for slope is an M. So anytime you see slope, you're going to see the letter M, and they mean the same thing. So to find the slope of a graph, so what the M is the M is your rise over run, or the change in Y over the change in X. So it's always like the up and down over the left and right. So when we count the slope, you always want to read it from left to right. So we're going to start at a point on the left and then move to the right. So I'm going to start at this point and make my way over to this point. So to get from point to point, we're going to go down 1, 2, 3, 4, 5, 6. So I just went -6, and then 1, 2. So I went 2 in the positive direction. So for my slope, we know slope is y over x. So the y value was -6. The x value is 2. Then if you can't simplify the fraction, you should. So that simplifies to -3. So my slope here is -3. Again, on number 4, we're going to start at the leftmost point. So here's our leftmost point. And we're going to go 1, 2, 3, 4. So I went up 4, so +4 to the right 1. So my slope is 4 over 1, which 4 divided by 1 is just 4. Finally, on 5, here's my leftmost point. So I'm going to go 1, 2, so up 2, and then 1, 2, 3. So we went up 2 over 3. So always the rise over the run, or the change in y over the change in x. So that's how slope looks on a graph. Finally, we have slope just using 2 points without a graph. So we have a formula for this. It is this formula. So the slope equals y1 minus y2 over x1 minus x2. So keep in mind that the first coordinate and the first x coordinate and the first y coordinate must belong in the same ordered pair. So what that means is if I were to call this x and y, because they're both the first pair, they both get the 1s. And then the second pair, they're also an x and a y, but because they're the second pair, they get the 2s. So when I write this equation to find slope, we're going to do y1 minus y2. So y1 is the 5 minus y2 is the 4. And then on the bottom, it's going to be x1, so 3, minus x2, which is 1. So 5 minus 4 is 1, 3 minus 1 is 2. And you can't simplify that, so it's done. Same idea on the next one. I would label it x1, y1, x2, y2, and then set up my fraction. So y1, 1 minus y2, -3, and then x1, -2, minus x2, which is 1. So remember, if you ever see minus and negative, that turns into plus positive, or you can just connect it and make it a giant plus sign. So 1 plus 3 is 4. -2 minus 1 is -3. And you can't simplify -4/3, so it's just going to stay that way. Again, I'm going to label just so I don't get confused as to what's what. So we're going to do y1 minus y2 over x1 minus x2. So 2 minus 1, I'm going to write down here, or 2 minus 2 is 0, and then 1 minus 5 is -4. Ooh, 0 on top. If 0 is on top and you divide by a number, that's just going to equal 0. So my slope here is 0. So in this next one, we have our x1, y1, x2, y2. So if we do y1, -1, minus y2, and then x1 minus x2, this time we get -4 over 0. Ooh, so if 0 is on the bottom, that makes the whole function undefined. So if you type this into a calculator, it's going to say error, and it means that it's undefined. So you are not allowed to divide by 0. So 0 is okay on the top, but not on the bottom. All right, this is our slope lesson. So try it out, and I hope it goes well.